Hi, this is János, it's Real World Audio, and today we are witnessing the birthday of the half-blooded prince. And you are seeing my darling amplifier, and I'm calling him half-blooded prince because he is kind of a pure darling, but he is not that pure, hence the half-blooded nomenclature. And why is he half-blooded? Because we have only the basic Hammond 125 ESC output transformers, which are not high quality output transformers, but the most basic ones that you can put in any darling, and that pretty much disqualifies it from being a pure darling. And also the wiring, you see, it's a little bit of a hodgepodge. It's whatever wires I had, that it has some Kimber wire, it has some Rome wire, and also some antique sterling silver wire, plus fine silver, all kinds of mixes, whatever I had in my junk box basically. And also the connectors, the speaker binding posts are pretty low level as well. So these things are which stick out pretty badly, and kind of are the Achilles heels of this half-blooded prince. But other than that, it is really good stuff, really top-notch, and with the help of your generous servings of coffee, I can transform him in time into a true prince who is not half-blooded anymore, so that I can get silver and redo the wiring with silver wires bit by bit, increase the quality there, get proper binding posts, and also the what needs like the true big coffee infusion is to change these into some serious Hashimoto beasts, but that will come much later on, and it's really depending on you. So far I cannot complain. I am getting much more generous servings of coffee than I ever imagined, and actually tomorrow I'm getting the first big baby that I bought from the coffee that you have donated, and it bears the name Hashimoto, and it arrives from Japan. And actually it would have arrived today, but I was at work, so FedEx will try to redeliver tomorrow, and it will be a surprise. I will do an unboxing video with either Machi or Kintaro. I will see which cat will be available. I will need to book an appointment yet with them. And Machi is here with me, and she's asleep at the moment, so probably I have to talk to Kintaro about it. So back to the subject of this amplifier. As you see, and as I have shown it, this is the birthday. Maybe did I show it? I kind of forgot about it. I just wanted to show that this little piece of wood with that inscription on it was inside this amplifier. It was resting here for almost 20 years. This was the one that had the Sprague atom capacitor bank that used to be its original capacitor bank here, and as you see, there's a date on it. So this is the date when this amplifier was originally built, year 2004, January 10 in Honolulu. And this was built not by me, but by my good friend Tamas, and this was his very first project ever. So before that, he never did any kind of electronics work. He bought a soldering iron just for the purpose of doing that. He consulted with me, and we set up the project, and he built it, soldered it, did everything completely on his own as his very first project ever. Before that, he didn't even make a pair of interconnect cables, nothing. This was his first project in life. And it served and operated perfectly without a single glitch or fault or hum or anything with the original tubes up to about a year or two ago, when I started to notice some noise developing from some issues with some of the connections. The soldering on one of the tube sockets started to get a little bit noisy and worn out, so I decided I will just recap and redo the whole amplifier now. And I really hope to be ready by the 19th birthday of this amplifier. Sadly, I'm 3 days late, so this is really a belated birthday party. I'm going to turn it on the first time, and it's going to be a sequence about, a demonstration on the sequence how you should turn on the amplifier the first time you are ever turning it on. So for that, what we need is a variac. So this is my variac here, and you can get variacs nowadays pretty cheap. If you look on eBay or online, I don't know in which country you live, whether it's cheap or affordable, but in the United States, online you can get one for about $100 or less than $200. It's a no problem and a no-brainer. I would say for a DIYer, if you are building tube amplifiers, it's absolutely mandatory to have one. And here, this Heathkit of mine, back then 20 years ago, I bought this for $5 in a thrift store. So look at thrift stores, used like pawn shops and stuff like that. It's a Heathkit variac, and here it has the AC ampere scale, so it shows the consumption, the power consumption of the device that is being fed by, and here it shows the AC volt scale. So you can adjust the supply voltage from 0 to 150 volts. We are here in the United States, so the line AC is 120, so you can go below 120 down to 0, but you can go a little bit higher, and you can simulate conditions, what happens when there's an over voltage condition, such as when there's a power line failure, and when the power comes back up, it's going to be an over voltage. So after electricity goes out, it comes back, you might experience like 130 volts or 135 volts, something like that. And if you are really curious, you can also try that out with your variac, but I do not recommend doing that when you first start your amplifier. I would say never ever do that when you start with a project. And even with working amplifiers, do not just crank them up to 135 volts. You are just going to shorten the lifespan, and if it's not built to withstand such voltages appropriately, which I would say none of the commercial amplifiers are, then you are going to severely damage or destroy them. My amplifiers that I design and build, they can easily withstand 135 volts line AC over voltage for short periods, no problem with that, but you can't do that with your whatever brand amplifier that you get, especially the ones made in China. Let's see, how shall we proceed? So first of all, plug in your power cord into the isolated output and turn down the voltage knob to 0. Make sure that your power switch is on. So now the power switch is on. So now what we can do, turn on the variac, but first make sure it's down to 0. I just did that. So now we have turned it on, the light is on. But there's nobody home yet because we are down to 0 volts AC. So what I have done also in the meanwhile is that I have placed a voltmeter on the AC scale onto the primaries. Can you see something? I can't see it. The screen is too small for me. So these leads, okay, can you see that? These are like alligator clip leads. So I just clip them on. If you have leads like that, that's perfect. If you don't, you can place your regular leads like holding with your hands right there. Fine, you can read it. But for this video's sake, it's much easier if it's constantly on there and I can have the use of my hands to explain and do other stuff. So what we do now is let's just turn on the meter and explore. Maybe I can zoom. Shall we? Do you see my meter? I don't see my meter. It's there. Okay, so I either show the meter or I show the variac, but you don't see both. So maybe now you can see the meters, kind of both. All right. So what we will do now, I will have one meter constantly connected to the line AC to measure it, and I have another meter that I will also set on the AC scale, and I will use that to measure the filament voltage. So I will measure the voltage on the tubes. And how can I do that? First of all, here these resistors, you see, they are coming from this transformer. So this is here supplying the input tubes, the 8532, 6J4 or CV5311. This is the same tube, just different grades of the same tube basically. So that's the driver tube, and this 6.3 volt filament transformer is feeding it, and that's why I'm touching everything here, because the voltage is still set to 0. So there's no voltage whatsoever there. But once I start cranking up the voltage on the variac, then no hands inside, okay? That's very, very important consideration. And also important that when we turn it on with the variac, there will be live voltage inside the amplifier. So please look at this as a demonstration on my part and don't attempt to do it at home on your own unless you are certified or you have been qualified to do this process by your own. If not, especially if you are a minor, then do not attempt to do that, because there will be one thing you can succeed doing: killing yourself or burning down your home, and you don't want to do that either. And if you do that, that's explicitly at your own responsibility, because I have explicitly warned you not to do anything like that when you are not qualified. Sorry for those of you guys for whom this is obvious, but I'm obliged to say it because for legal purposes. Okay, so now we can continue. So here we have, this is the filament transformer for the driver tube, and we have actually two filament transformers for the power stage, because I have not mentioned yet that this is a twin darling. It's something really special. This is one step beyond the darlings that I have been talking about on my channel, and which are the 6J4 driven 1626, the darling tubes. Here we have the option that you can use either the darling tubes or the type 59 pentodes. So that's why this is a twin darling, because if you plug into these two tube sockets the 1626 triodes, it will be a pure darling. And if you take those tubes out and you plug the 59 tubes into the other tube sockets, then you will have a 59 darling basically with different power tubes. Why is that? Why I did that? That will be the subject of a different video. For now, I have the type 59 tubes connected, so I will be able, sorry, that was some fireworks from one of the neighbors. They still think it's New Year's Eve. So back here, so we have the type 59 tubes, which have 2.5 volts for filament voltage. That's why I need a different dedicated filament transformer for them, and another dedicated one for the darling tubes, which is a 12.6 volt filament. So what we are going to do, we are going to ramp up the voltage, and we are going to see what is the filament voltage, and we are going to ramp up the voltage gently, because that's the purpose of the variac, so that as the voltage increases, the supply voltage increases, we can monitor the power consumption, and if we see that the power consumption is shooting up, then there is a problem. You have to stop. And it's here, it has like two scales. It has 3 ampere scales and 1 ampere scale, and you can choose which scale we are using it at. So it was on the 3 amp. Let's change back to the 1 ampere scale, because it should consume less than 1 amperes total, so we can see the movement much better. And now we are hitting already 16 minutes, so I'm going to hit pause on the video, warm up my, actually this is not even coffee, this is hot chocolate really. So now you guys must be super confused, because there is this buy me a coffee thing, and I talk there like you can buy me tea, and I'm drinking hot chocolate. So this is really far-fetched and very confusing. If you ever used buy me a coffee, then you probably have had a really good laugh now. Those of you who never used buy me a coffee don't know what I'm talking about. Just like, what is this guy about? Has he lost his marbles? So anyway, now I'm going to go back to my serving of hot chocolate, or actually now it's cold chocolate. Now it's pretty cold up here in Mililani actually. So I'm going to stop it, heat it up, drink it, and then continue. Let's fire it up. Have an awesome day. Bye bye.